Hello again. Welcome back. We are talking about section 3.4, optimization and elasticity of demand. In this final video for the section, we're going to tackle, define, and examine price elasticity of demand. Let's get ourselves there. So price elasticity of demand is basically the notion of how increasing a price affects the demand, not just as a rate of change, but sort of a relative or percent rate of change. So if we sell Q items at a unit price of P each, and then we assume that this demand function is differentiable for convenience, then our definition is price elasticity of demand is the following thing. So we often use the capital letter E to represent this, or economists do. So it's negative P over Q times dQ dP, so the derivative of quantity. And really what's going on is that this is Q prime, so dQ dP on top, and then it's being divided by the ratio of quantity to price. Now, if you divide by Q over P, this flips over and gives you the reverse of that. It gives you times P over Q. But that's basically what this elasticity thing is going for. So what that means is we're not just looking at the rate of change in demand, we're looking at the rate of change in demand relative to this ratio of quantity and price. So basically, it's giving us a percentage increase in demand versus percentage rate of change in price. Okay, so let's try this out. So let's say we're looking at high-end headphones, and the demand for this is given by D of P. So this is how many pairs of headphones demanded when you charge P dollars for each set. And the question is, what is the elasticity of demand when the headphones sell at $500 per pair? Okay, so, oh, I should mention this is actually, I can't say the brand yeah, well, can't say the brand, but I did do regression on a particular brand of popular headphones, and the regression model is actually pretty accurate for that quadratic right there. Okay, so price elasticity is defined to be, all right, so we're just grabbing our definition again. The Q in this case is D of P, so just to copy the letter from the definition, Q is that quantity output. So let's recognize that the main thing that we need to figure out here, price is taken care of, Q is a formula they just handed us, so dQ dP is really where it's at. So that's what we're up to down here, is finding this derivative function. And as usual, I mean, in this class, basically you can fall asleep and wake up with me calling on you, and you could just answer or take the derivative, and you'd be fine. So this is a case where that's still true. Derivative of this is all power rule, so not a big deal. We'd have 0.02p minus 20. That's the rate of change in demand. Okay, so let's put it all together. So P over Q, let's do some color coding here. So here's Q. And keep in mind, price is our independent variable, so price is staying exactly where it is. So P doesn't have to do anything special. And then our dQ dP, the thing we just figured out, is this derivative tacked on to the end. So now our elasticity function is in terms of only price, which is great because that's actually what they gave us. They told us $500 per item. So per $500 for the headset gives us 500. Replace all the P's with 500, and we'll get some number. I think pretty nice number, 2. Okay, so 2 is the final answer, which is great, but we were also in charge of interpreting this result. Okay, so this is one of those templated things that we can just kind of copy. So we expect each 1% increase in price to cause an associated, and that you can basically write that thing every single time, because that's just part of the definition of elasticity, price elasticity of demand. So 2%, that's the number we came up with. So 2 is the actual value. So if this had been 0.1, it would be 0.1%. So the thing we're coming up with basically is already a percentage rate of change, assuming that we also have a percentage change on bottom. So it's always a decrease because we're assuming the law of demand holds. That is that if you increase price, then quantity demanded will decrease. So just to see if we can make sense out of this, so headphones are a luxury good. That is, they're not like bread, for instance, or some other food. housing, so we've got an increase in demand would mean that if we increase price by 1%, 2% is proportionally a greater response than the 1% change in price. So if we increased price by 1%, we're anticipating demand would drop by 2%. That's a more dramatic response than we'd see in some other, for some other products. So it turns out there's some definition to go around this, some terminology that helps us relate relative elasticities. So if we've got an elasticity that ends up being larger than 1, then we say that demand is elastic. And basically what that means is that if you make a change in demand, a change in price, then demand will have a relatively large reaction to that. So a 1% change in price is going to have a greater than 1% effect on demand. So one interesting result of this is that we also see this change in revenue. So if you decrease price, then you're going to see an increase in revenue. So let's put this in perspective. So with elastic demand, an increase in price causes demand to drop by a bunch. So if you increase the price, proportionally, you're not going to make that up by having more, by having people buy it. You're going to lose more in demand than you gain by increasing the price. So consequently, increasing the price would cause revenue to go down, the opposite of the converse of this statement, I guess. So if you decrease the price, that's the way to see revenue get bigger when demand is elastic. So then, of course, we've got the other side of this. If demand is, if elasticity is less than 1, then we have inelastic demand. So this is the case where you increase price by some amount and demand drops a little bit. It's inevitably going to drop some, but it doesn't drop as much as price does. So if you increased price by 1%, maybe demand only drops by 0.5% or 0.2%. So in that case, we would say you have inelastic demand. And in that case, it's actually a good situation to increase price. If you increase the price, you're not going to lose as many people as you're going to gain in revenue from having charged more. So increasing the price when demand is inelastic is going to result in an increase in revenue. And then right in between these two things is unit elasticity, or unitary elasticity, sometimes written. So what that means is that if we see a 1% change in price, we're going to see about a 1% change in demand. This is actually an ideal scenario for revenue. So, and it turns out that in particular, revenue is largest when you pick a price that has demand unit elasticity. You sort of snuck right in between elastic and inelastic demand. So just to reference the example that we had a minute ago, remember when we plugged in 500 for elasticity, we got 2 as the output. So that means that the demand for headphones at that price was elastic. In other words, increasing the price by a little bit is going to cause demand to drop off by a bunch. And maybe that's because of this luxury good nature. Sure, you need food to survive and you may want headphones, but maybe you're not willing to pay that extra 20 or 50 bucks for the headphone, the really high-end ones, and you're willing to go get something else instead. If we had picked a different input though, if we had gone with 200 and calculated elasticity again, we would have gotten an elasticity of 0.5. Because this number is less than 1, we're saying that demand is inelastic. That means that increasing the price by a little bit is always going to drop demand by some, but it's not going to drop demand by enough that we're not still making more money. So at this price, increasing by 20 or 50 bucks would probably result in increased revenue for these headsets because demand is not adjusting quite as quickly as the price is. That's it for section 3.4. We'll be back for our final section of chapter 3 in the next videos.